3.2, number of subsets and like items. So the total number of subsets of a set, so what this would be is basically the total number of combinations. So a subset of a set, you can choose between 0 to n elements from the set to be in the subset. So 0 means that every subset, like every listing of subsets, is going to have a null set, and every listing of the subsets is going to have the universal set, right? N elements, all of the elements. So the total number of subsets of a set of n elements, what we would technically do is do n choose 0 plus n choose 1 plus n choose 2 all the way to n choose n. However, we're going to learn this later, but this is going to be 2 to the exponent n. So each element can either be included or excluded, and that's where this 2 comes from. So include in the subset or exclude from the subset. And then there's 2 options, like there's 2 ways of choosing each item. Now, just a little tidbit on the null set. I know that we went through this before, but the null set contains 0 elements, okay? We can either denote it by this, okay, bracket with nothing in it, or a bracket with a null in it, okay? You cannot put a 0 in here. It's specifically a null. If the null set is excluded. So there's some situations in real life where you would have to exclude the null set because it doesn't make sense. And then all we would have to do is 2 to the n minus 1. 1 being the situation of the null set. Okay? And this is if the subset must contain at least 1 element. An example of this is like if you're shopping on Amazon and you're putting in an order. You can either include items or exclude items. However, at the end of the day, in your shopping cart, if you were to put in an order, your order would actually have to have 1 item in it. It can't be like an empty shopping cart. Then there's no order. So by logic, you would exclude the null set there. Okay, determine the total number of subsets. So how many different subsets are there if the universal set has 7 elements? Well, that's just 2 to the 7. 5 elements. Well, that's just 2 to the 5. And k elements, 2 to the k. So whatever k is, you just sub it in. Okay? A restaurant offers 4 types of appetizers on the menu. Apps. How many possible ways can a customer choose to order appetizer or appetizers if there's no restrictions? So if there's no restrictions, there are a 2 to the 4 way of choosing appetizers. And if you actually read this, you might be really confused because you might be thinking, oh, but like how many appetizers are we choosing? Well, we don't actually know. So it's so general and so vague. It's just 1 or 2 or 3 or 4 or 0. And essentially what this is it would be all subsets of 4 appetizers. So as a visual, so you have like chicken wings, and then you have bruschetta bread, and then you have chicken bites, and then you have, I don't know, a dip. We can either include or exclude the wings, include or exclude the chicken bites, include or exclude the, chicken, bruschetta bread, sorry. And either include or exclude the dip, right? So if you think about it, it's 2 to the 4. There's 2 options, 2 options, 2 options, 2 options. But if they have to order at least 1 app, all we do is we get rid of that 1 null set. So we just do 2 to the 4 minus 1. Okay? When ordering a pizza, the base pizza comes with dough, sauce, and cheese. Okay? If the additional toppings that are available are pepperoni, sausage, green peppers, pineapple, mushrooms, onion, chicken. How many ways can a pizza be ordered if there's no restrictions? So we can either include or exclude all of these 7 items. So that's 2 to the 7. Now, if the pizza has to have at least 1 topping, we just subtract the null set. Okay, so applying the formula for the number of subsets. In how many ways can a committee with at least one member be appointed from a board of 5 members? Okay. So there's 5 members. There's member 1, 2, 3, 4, 5. Again, either include or exclude. Include, exclude for all of them. So a way that we can appoint them is 2 to the 5, but at least one member has to be appointed. What this is telling us is there's no null set. There has to be a committee. So we subtract the 1. Now, combinations of items in which some are alike. So here's the thing. If at least one item is chosen, the total number of possible selections from P items of one kind, Q items of another kind, R items of another kind, etc., is going to be, instead of the P, is P plus 1, Q plus 1, R plus 1, etc. So let's actually talk about this. P plus 1. Say there are 4 items. Well, there's 4 plus 1 ways of choosing those items. We can either choose, i.e. choose 1 item, 2 items, 3 items, or 4 items. Okay, that's normal. But where does this extra 1 come from? That's the situation where we don't choose any of those items. So the plus 1s account where 0 items from this group are chosen. Okay, so we're going to multiply all of the ways that different items can be chosen. But then at the end, we subtract 1. Well, where does that 1 come from? Well, that's the one situation where we didn't choose anything from P. We didn't choose anything from Q. Nothing from R. Like 0, 0, 0. Nothing across the board. We're taking away the null set. The situation where no items are chosen. Okay, so example 5. Veronica is responsible for stocking the fridge at the gym. The fridge can hold up to 3 cases of water, 6 boxes of protein bars, and 4 tubs of protein. If the fridge is empty, how many different purchases can Veronica make, assuming she makes a purchase? Okay, so you can either, so it's going to be 3 plus 1 for the water. You can either order 1, 2, 3 or 0 cases of water. For the bars, you can either order 1, 2, 3, 4, 5, 6 or 0, right? Those plus 1s or 0. Boxes of protein bars and tubs of protein, 4 can fit. It's going to be the 4 plus 1. You can order 1 or 2 or 3 or 4 or 0. But we're assuming she makes a purchase, so we're going to go ahead and subtract the null set. So I get 4 times 7 times 5 minus 1. So 140 minus 1, I get 139. Okay. For B, assuming that she wants to order a minimum of 2 cases of water. So there's actually a lot that goes into this. So for the water, at least 2 cases. So our waters are now 2 or 3. Okay. There's no option to get 0, 1 or 0 or 1 anymore. So there's 2 ways that she can order water. She can order 2 waters or 3 waters. Okay. The bars are still a 6 plus 1. The protein is still a 4 plus 1. There's no null set over here. There's no null set because we know she already ordered water. So there won't be a null set. So simply 2 times 7 times 5. There's 70 ways that she can order. Okay, example 6. Emma is packing her suitcase for a weekend trip. The suitcase can hold up to 3 shirts, 2 pairs of pants, and 4 pairs of socks. If the suitcase is empty, how many ways can Emma pack her clothes, assuming she packs at least 1 item? So that just means we're going to subtract the null set. So she can pack 3 plus 1 shirts, 2 plus 1 pants, and then 4 plus 1 socks. So 4 times 3 times 5 minus 1. Okay? 59 different possibilities. Okay? What if she's not actually required to pack any items? So she's just bringing an empty backpack. Maybe she wants to go shopping on her trip. Well, this is going to be the same, except for we're not going to subtract the null set. So we're allowed the null set this time. Okay? So this is simply 4 times 3 times 5, which we get 60. Now, what about if she has to pack at least 2 pairs of socks? So, shirts are going to be the 3 plus 1 still. Pants are going to be the 2 plus 1 still. But socks, if she has to pack at least 2 pairs and she has 4 pairs of socks, she can either pack 2 or 3 or 4. So that's 3 different ways she can pack socks. Okay, no null set. If you want to make a note, because she packs socks. We're guaranteeing that she packs socks. So I get 4 times 3 times 3. So I get 36.